Well, let's start. Hello, everyone. Welcome to our lesson. Today we will talk about Docker basics. It is a kind of overview lesson about Docker technology for manual QA engineers. And before we start, let me introduce myself. My name is Maxim Usmanov, as you can see on the slide. I'm experienced software engineer, and during the last 7 years, I work as a quality assurance engineer. As you can see, I have quite a long experience of working in different companies or in different roles. As you can see, I worked as a software developer also. And why it can be interesting for you in terms of this lesson, because in every company and in every role, I used to use Docker. So why we are here, or why you are here? What we're gonna do today? Today we're gonna learn what is Docker, and the most important today we will talk about why do we need to learn Docker, because when you learn something, you spend your time, and first of all, you need to understand that it should not be a waste of your time. So that is important to understand why it is useful to learn Docker, or why it is needful or important for you. And of course, we will look on how to use Docker, how to deal with this technology. And I guess most of you already heard something about Docker, or some of you maybe read the student book about Docker. So please help me to answer this question. What is Docker, in your opinion? Please raise your hands. Please write in chat your answers, your opinions, your ideas. Yes, Maxim.
I guess Docker is the program to create isolated environment.
Mm-hmm. Actually, you are right. Docker is a program, and in general, it is just a program for containerization. And looking a little bit further, you gave an example of what is an advantage of containerization. And in this case, we need to understand what is containerization. If Docker is a program for containerization, then we need to have a clear understanding what is containerization. And containerization is just an approach to run applications in isolated environment, containers. So you are right when you say that Docker is a way to run isolated environments. To have a better understanding what is isolated environment and what is container, first of all, we need to recall how to run applications in traditional way. In traditional way, in traditional approach, we usually use our PC, or we use some server, which has some hardware, and we use this hardware in our PC or server to run some operating system. I'm pretty sure that you know some operating systems on your PCs. You can use Windows or Mac OS or Linux. these all are operating systems, and only inside these operating systems you can run your applications. But in general, applications cannot just run inside operating system. They need to interact with it. They need to interact with API of operating system, and for that purpose, they use some system libraries. It is a kind of shared code, system code, and this is the reason why you cannot just take any application from Windows and run it easily on macOS. If you want to run some application from Windows on macOS, you need to install some Windows libraries. And the same with Linux. And what is environment in this case? In this case, operating system plus some libraries is an environment, and inside this environment we can run applications. Now let's look on more the industry way of running applications. In IT industry, we usually have two options to run some product applications. This image is from official Docker website, and on the right side image shows the way how we used to run applications without containerization. We had some infrastructure. Let's say it's a stand in data center with some hardware. And on the top of this hardware, we have a hypervisor. It is a tool, or I would say it is a set of hardware and software tools that help to run multiple virtual machines on the same hardware. And inside virtual machine, we can run operating system. So we can run multiple virtual machines, and inside each we have independent operating system, and we can run many applications that share the same operating system. And applications inside one operating system are not isolated from each other, but applications from different operating systems, like on this image, are isolated from each other. So application A knows nothing about application B, and application B knows nothing about application C, because they run in different operating systems. And what do we have with containerization? With containerization, we have infrastructure, maybe the same server stand in data center, and this stand runs only one operating system. And on the top of this operating system, we can install Docker or any other program for containerization. And this program for containerization can help us to run applications in different containers. And on this image, we can run many applications that are isolated from each other because each application runs in isolated container. And this container was virtually created by Docker. So the main difference that you can see here is that we do not need to run operating system for every isolated environment. We can use only one operating system. And this is the main reason why Docker is more comfortable and more modern way for isolated environments. We don't need to spend more hardware resources on running operating systems, because every operating system consumes a lot of CPU memory, and both SSD memory and RAM memory. Now let's think about why do we need Docker? You come here to learn what is Docker, but it is important to understand why you may need Docker. And here again, please share your ideas. Try to answer this question. Guys, why do you need Docker? How do you think? Please raise your hands. Please share your ideas via chat. Any ideas?
Maybe as testers with Docker, we could test some application like in one environment, but with different setups.
I agree. I agree that if you need to run any application, you need to run it in some environment. And if you need isolated environment, why don't you use Docker? That is correct. Let me suggest some more ideas. I would say that if you learn quality assurance, if you learn something from quality assurance, I think you would like to find a job. And in many different job descriptions for quality assurance engineers, there is mentioning of Docker technology. So quality assurance job in general may require knowledge of Docker. The second reason, when you apply for this job, I think you will have a job interview and they can ask you about Docker. And of course, if you already entered a new job, work in a team and your teammates may use Docker, and you need to be able to collaborate with them. You need to understand what do they do. You need to be able to interact with the environments that they created. And this is quite obvious, and let's proceed to less obvious things. In general, once again, why do you need Docker is just for containerization. And you may need containerization for many various things. First of all, you may need containerization as a QA engineer for highly portable environment. What does it mean? It means that if you need to run some complicated application with complicated dependencies, just imagine how it can be difficult to install it on your local PC. It may require database, it may require maybe some programming languages, some additional libraries, and other things. And the most or the less pleasant thing is that it may conflict with other applications that you are already running. Just try to remember good old days when you tried to install some games on your PC. You could buy a CD disk and you could try to install a game, and something could go wrong just because this application may require some additional environment, some additional dependencies, such as DirectX for running graphics on Windows, for example. Another option why you may need to use containerization is an ability to run multiple environments efficiently. Docker or any containerization program lets you run many different containers on single operating system, hence in your on your PC or on one server. So you may be able to test different versions of applications, or you may be able to test different applications at the same time, and they would not conflict with each other because they are running in independent containers. And each container is a kind of independent, isolated environment. And as Maxim said, you may need to use it for testing purposes. And let's look at general SDLC, how it may happen. I wouldn't say that it happens every time in every company, in every team, but how it may happen in general. Developer creates some container. We will talk a little bit later how it happens. Developer can build container which contains application plus environment, and this application you as a tester will need to test. And you can just run, or you can just run the same container with the same application with the same environment. You don't need to spend your time on building this environment and each dependency one by one. And after you tested this container, this environment and application, the same container can be deployed to production. So you should not worry about environment differences. The same thing that you tested will go to production as is. So it is important here. You should not worry about some configuration differences, and you will catch less bugs in production. Now let's learn new words about Docker. I would say that Docker technology is quite huge, and there are many different terms, but today it is just an overview. So in scope of overview, we will learn on only main terms. And I will try to give you some examples from life for better understanding. So let's start. The first new word for us here is image. What is image? Image is a kind of archive that can be unpacked and used. The best comparison that I can imagine from life is the same game from a CD disc or Blu-ray disc. If you have a PlayStation or Xbox, you can buy a disc with a video game, and on this disc there is an image of the game that you're gonna play. But when you when you insert the disc into your PlayStation or Xbox, the game is running, but actually the game is running from this image, but it does not overwrite this image. The image is immutable. It cannot be modified. It can be just used as an archive with files that are used to run the game on PlayStation. So PlayStation just unpacks this image and uses files from this image to run the game, an instance of the game. Another important term is tag. Tag is used for marking images, for marking versions of images. The same as with games. Imagine that you have bought a day one edition of some computer game. Of course, it will have some bugs, and developers will learn about these bugs only through the time. And of course, they will try to fix these bugs, and of course, they will want to produce disks with updates. And in terms of Docker containers, we need to be able, in terms of Docker images, sorry, we need to be able to difference. We need to be able to understand the difference between images of the same images, but with different versions. So image can be released with version 1. After some updates, the second version of the same image can be released with some changes. The next term is registry. Registry is usually just a remote storage for images. The most popular is and default registry is Docker Hub. There, people who create images just push images. If they release a new version, they push a new image with another tag. The next term, the most important, is container. What is container? It is just an instance that we can run from an image. When you run your game on your Xbox, actually, it is an instance of the game from the image. You can give the same disk to me. I can run it on my Xbox from the same image, but I will run another instance of the game. You will have your own game progress. I will have my own game progress. So we have two different instances of from the same image of the same game, but they different instances. Now let's go to the most technical term today is Docker-D. Docker-D stands for Docker daemon. Daemon, as you may remember from Linux courses, daemon is just a background process. In Linux, guys who created Linux decided to call all background processes as daemons because this is something magical that we cannot see. And I will explain a little bit later on the next slide what does Docker daemon, but in few words, it just serves our requests from some Docker clients and manages all the Docker entities, such as images, containers, and interacts with registries. The next term is Docker client. Docker client is just a program that we can use for managing our Docker needs. Docker client only provides some kind of interface, command line, or graphical UI interface, user interface, and it just proceeds our requests to Docker-D. Now let's look at the same on the picture. On the left side, we can see an example of some Docker command line client commands. We will talk a little bit later about these commands, but in general, just look. Client is a command line program, command line command called Docker, and it can be run with some parameters. When we run any command with any parameter, it goes to the Docker daemon. And if Docker-D decides that it needs to interact with images, it interacts with images. If it decides to run container from image, it runs a container from image. Here is an instance of Docker run command, and here Docker-D runs containers from an image. Here's an example of Docker build. Docker build is used for building images. So Docker-D just builds an image. If you use Docker pull, this command is needed to pull an image from the registry. So here Docker daemon goes to the registry as you may remember, the default registry is Docker Hub. I will show you the website a little bit later. So everything what Docker does just serves your requests that you send from the client. There are two options available by default as a client. You can use command line interface, or you can use desktop client with graphical user interface. Now, I would suggest to make a short break, but before we make a break, please ask your questions if you have any. Please raise your hands, or please write your questions to the chat. No questions so far. So I would suggest you to make a break, to let new knowledges to lie layer by layer in your head. So I will wait for you in 30 minutes, so in 4 minutes. So now it's a break. Please get back soon. Well, 1 minute left till the end of the break. Guys, if you have any questions, please raise your hands. Please write your questions to the chat. We will continue in half of a minute.
Will we speak about container images layers?
Yes, we will speak about container images layers just for brief understanding. Time is up. Let's proceed to the practice. And before we start, let me show some agenda of our practice. What we're gonna do today, right now. We're gonna look how to install Docker. We will play with images, containers. We will have a short Docker file overview together with layers and instructions, but very brief because we are limited by time. And we will have short desktop client overview. How to install Docker. I would not show any demo how to install Docker because it is pretty simple. All you need to do is to open official website, download Docker version for your operating system, install it in the most general manner, and here you are. Your Docker is installed. Regarding playing with Docker images and containers. For you, I have added some cheat sheet with Docker commands about images and about containers. You don't need to learn it by heart right now. I'm not going to read and explain all of these commands. We will just do some practical things in command line, and I will explain what I am doing, what parameters I am using, and why I am doing that. So let's proceed. Let me share Visual Studio Code. Can you see Visual Studio Code? A dark program.
Yeah.
Thank you.
Yes.
That's great. So many voices. That's great that you are listening. What is it? What is this program? This program is Visual Studio Code. It is development environment. I'm using it for demo because it has inbuilt text editor, and it has inbuilt terminal. Everything what I am doing in text editor, you can do in any other text editors, and everything what I am doing in terminal, you can do in any Linux or Mac OS terminal as well. Or you can do the same in Windows command line with Docker commands, but some commands I will use from Linux. So I'm pretty sure that you can do the same on Windows if you use PowerShell or another Linux command line emulator. Well, let's start. Now we're gonna use Docker command. Docker command is a Docker client, command line interface client. If you run Docker, it will show us some kind of help instructions. Oh, sorry. Some kind of help instructions, and it shows us many different parameters, commands, and it says that if you need to learn something about any command, you can just add help. For instance, I can run docker run help, and it shows me some other flags that I can use together with this command. Now, let's try to understand what is isolated environments in Docker. Let's imagine that you have installed Python on your PC. Python version. Oh, I don't have Python. I have Python 3 on my PC. It is a little bit outdated, but I cannot update it because I have many tasks or many programs that work only with this version, and I don't need I don't want to update it. But for testing purposes, I need to set up some working environment with newer Python. I can pull an image with Python. Look what it does. It downloads Python image. I use docker pull command. This command just pulls an image with name Python from default Docker registry. And let me show what is default Docker registry. Just a moment, I will change the window. Look, we can write in Google Docker Hub. We can go to the website, and here we can see the search input box. And here we can search for Python, for example. Look, here's a Docker official image Python. We can choose it and look at the right side. It says you can use this image. You can pull this image using this command, docker pull Python. This is exactly what I have typed to download this image. You can pull many different images. You can search for image with any programming language. For instance, Golang it's a language by Google, maybe Kotlin, Java. Here is Java, Docker official image. Look, it has Tomcat application server. It has Node.js. It has many databases. So it provides a storage of many different images, and inside these images, there is a archive with files from which you can run isolated environment with database already installed and set up, or any other programming languages. Now, let me prove my words for the Python. Look, now we have just downloaded an image with Python. Python is the name of the image, and here it shows latest. What is latest? Latest is a tag. When we learned new words about Docker, we learned the word image. Here is it, image with name Python, and latest is a tag. Latest is a default value of the tag, and it means the latest version. We can provide any specific version that we can find on Docker Hub website. In this example, it is not really critical. Let's use latest. Now I can run container from this image. For this purpose, let's use command docker run, and we need only provide image name. Let's do that. What happened? It says actually nothing to us, no output. What happened? I have just started container, and we can use Docker container PS, the same as in Linux. PS shows processes. We can check all the containers processes. Look, it shows an empty table. But where is my container? I have typed docker run Python, and I expect some running container. The real thing and explanation what happened is that docker container PS command shows only running containers. If I want to see all containers, both running and not running, I need to use -a parameter. And look, here it shows the same table, but it shows that container from image Python was created about a minute ago. This is my container that I tried to start, and it shows that it exited about a minute ago. And it has some strange name. We will talk about it a little bit later. What is container ID? Container ID is a unique identifier of container. And we can use this container ID in any operation related to any particular container. If we want to operate with container, we need to provide something unique to the Docker as a parameter. For example, if we want to let's say delete this container, we can use Docker rm, which stands for Docker remove, and we can provide this container ID. And after that, it is removed. Look, I typed Docker container ps -a to show all the containers, and now container is removed. Why my container started and at the same time it stopped? Because Python image is an image, is a base image. We cannot use it. We cannot just run it without any input. And to provide any input, we can run Python image in interactive mode. To run an image in interactive mode, we need to provide parameter -it, and we need to provide the same image name. Now look what happened. It didn't close. It showed me a version, much more fresh version of Python, and here is a Python command line, and I can use Python language here. I can press 1+1. I can use print function. So it works like a Python command line. Let's exit it. And while I am using in interactive mode this image, it is running. When I'm not using this image, it is closing. If you run an image with any service, I will show you an example a little bit later, container will run forever until it hangs or stopped or killed. Now let's go inside container one more time, but with another example. Let's download another image, BusyBox, with name BusyBox. BusyBox is an image that is based on Linux with many useful Linux commands. Let's pull this image. And we can connect to this image. We can connect to the terminal of this image inside this image using interactive mode again. Look, by default, if I connect to the BusyBox, it provides me terminal access. So I can use some Linux command. Right now I'm in a root. I can use ps, so the command to show all Linux processes. And inside BusyBox container, inside container that I run from BusyBox image, I can use some Linux commands, and ps aux command shows me all the processes that run inside this container. And inside this container, you can see only two processes. One is process that stands for the command that I have ran, and another process is a root process with ID 1. It's a shell. So it's a shell where I run commands. Let's access this container, and let's do the same inside my operating system, inside my command line on my PC. Look how many processes do I have. And once again, let's connect to the busy box. Once again, let's ask for the processes. You can see only processes, only two processes inside this container, nothing more. What it actually means? It means that processes inside container are isolated from my host operating system. My host operating system is macOS, and processes that run inside container know nothing about my operating system. They are sure that they run inside some Linux operating system, and they have no idea about my macOS PC. And the same with my macOS PC, it actually doesn't know about these processes until I do some magic. But it is a little bit more advanced level. What's next? Now you understand that you can run any kind of environment from an image. And now let's try something that is more related to your job. As a manual QA engineer, you may be asked to test some application. Let's say some service. As an example of service, I suggest to test WireMock. WireMock.org website provides a program. This is quite a popular command, program for testing. WireMock is just a mock, HTTP mock. This is a program which you can use for testing. You can run WireMock, and you can ask WireMock to reply for some specific HTTP requests with some specific HTTP responses. We are not going to use WireMock as a mock today. We will use it just as a service, just for understanding how to operate with services in Docker. Let's go to Docker Hub and search for WireMock. It's here, and it says that to pull this image, you need to copy and run this command. Let's go back to the terminal. Let's pull this container, this image. Well, how to run container from this image? Once again, docker run and the name of the image. Now it shows log output from the container. Look, it blocked my terminal. I cannot do anything. I can do something, but it doesn't respond because it's a service. Service is up and running, and it will run indefinitely until I press Ctrl+C to stop it. But if I press Ctrl+C, let's look at the status of my container. For this purpose, I run docker container ps -a. Here I can see WireMock container from WireMock image, and it says that it exited 10 seconds ago, exactly in the time when I pressed Ctrl+C. But how to run container in the manner so that it would not block my terminal and I can interact with it. Pretty simple. I can use the same command docker run, but with -d parameter. -d means daemon. So the same as in docker d, D stands for the daemon and means background process. So it means that we will run our container in background process, so it will not lock our terminal. So let's provide image name, wiremog for some reason. And as an output, it shows me some magic string. What is this magic string? Let's look at Docker container ps -a again. Look, it shows me one more container from wiremog image, and status is up 15 seconds. And here in the first column, container ID, it shows me some short magic string. Look, this short magic string consists of 10 or more. Sorry, of 12 digits and letters, and it is exactly the same as first 12 digits and letters that Docker provided to me when I started container in daemon mode. It means that the real container ID is quite a long string, but when we run Docker container ps -a, it shows only first 12 letters and digits, and it is fine to use both. For some purposes, you can use long representation or short representation. It's not a problem. Well, while our process is running, let's think about other containers. It is not comfortable to work with Docker container ps when we have many dead containers. Let's remove them. And we have many options to remove them. We can use docker rm, remove docker remove, and provide, for instance, docker ID. Let's check again. Now we don't have a container that we ran from Python image. We have another option to remove container. We can provide a name. Look, this is table headings, and the last column is names. And here for the last container, it shows nice Herman name of container. This name was generated, was randomly generated by Docker when we started container. It is comfortable to rely on these random names because for us, for humans, it is much more convenient to remember such names rather than such ugly identifiers. So in the same manner as we did with Docker IDs, we can use container names for any operations with Docker container. So in this, with this command, we removed our container. Let's check it. It doesn't exist anymore. The second BusyBox container was removed. But it is not comfortable for us to remove containers one by one. If you make many operations, if you run many containers, make many attempts, it's not comfortable to delete one by one. So for this purpose, Docker developers added command docker container prune. This command will remove all stopped containers. Look, we have one container which is running, and it is safe because docker container prune command will remove only stopped containers. But it asks you about if you want to continue for safety purposes. And it shows IDs of containers which were removed. Look, so it removed these two last containers. Let's check it again. Now we have only one container, which is up and running. This is our wiremock container. What we can do with our running container? With our running container, we can connect to the logs. For these purposes, we can use Docker logs. As a QA engineer, it may be critical for you to troubleshoot some bugs, to localize some bugs, to attach logs, to report some bugs with logs to developers. So it is critical for you to know how to look at logs inside container. So this is our running container, and we can use, for instance, container name or container ID to look at logs. Look, I run Docker logs and container name, and I can see logs of the container. What it says? The log says that our service started on port 8080. And I expect that I should be able to send GET request using command curl to the local host, because container is running on my PC on port 8080. Look, and it says that it failed to connect to localhost on port 8080. It could not connect to the server. Why? This service is up and running. We can check it again. It is really running. Status, it is up for 7 minutes. What's wrong with it? The problem is that this service is running inside container, and it listens to the 8080 port inside container. 8080 port in my operating system, in my macOS, is not the same as the port inside Docker container. But how to connect to this service? Let's stop this service. To stop this service, we can use command docker stop, and we need to provide Docker ID or Docker name. Now the service is stopped. Look, status is exited 2 seconds ago. And now we can run our wiremock service again, but we need to provide additional parameters. We need to connect 8080 port with some from container with some port in my host operating system. How to do that? We need to use -p, which stands for port parameter. And first of all, we need to choose which port we would like to use for connection. I would like to use 777 port, and let's map it to 8080 port, which is inside container. After that, we need to provide our image name. So docker run -p our host port, our container port, and image name. Let's run it. But it locked my terminal again because I forgot to provide daemon parameter -d. Well, now it started. Let's check that our container is up and running. For this purpose, we can use Docker container ps -a parameter. And now we can see that our Docker image is up and running. And now let's try to connect to our service. Look, I provided 777 port that should connect to 8080 port of WireMock. So here I will type 777 port. Look, and I have response. I have response that access is forbidden. It is great. It means that WireMock, which running some kind of web server inside it, served my request. HTTP response 403 is a client error code, and it means that I have tried to access some destination that is forbidden for me. But it means that WireMock served my request. It means that I could connect to my WireMock, which is located inside container. Yes, Maxim, please ask your question.
I'm sorry, I missed. If 777 is your port on the host operating system. Right?
Yes, correct.
Okay.
I can do the same in Google Chrome. I can go by address localhost 777. Look, I have browser only in my operating system. I don't have it inside Docker container. And it shows me that servlet, just some kind of code inside WireMock, responded to me. When I tried to connect via 8080 port, I couldn't do that because 8080 port is not on my operating system. It is inside Docker container. And when we provided parameter -p, you can imagine it is a kind of bridge between my operating system and between Docker container that connected port 777 on my operating system with port 8080 in Docker container. Actually, what we did is named a port exposure. So we exposed port 8080 from our Docker container to our operating system. Now let's go back. What can we do next? Next, we can look at our WireMock logs. For this purpose, we need to know our container identifier, name or identifier. Let's use container ID. Why not? And let's check logs. Look at here we can see a new line. No response could be served as there are no stop in WireMock instance. WireMock is a program which engineers usually use to build mocks. Mocks is some kind of fake program. It is usually needed to replace some real program, and the main specific of mock is that you can ask mock to reply with some specific responses to some specific requests. And in this case, we didn't ask wire mock to reply with any responses to any requests. That's why wire mock says that it doesn't have any response for this mapping, and by mapping it means URL path, and by URL path it means some request. So in other words, wire mock doesn't know how to reply to our request. This is what this log means. We can try to connect by any another path for the same host. So we can try to connect to wire mock by any strange path. And it sent us a response that it couldn't surface because it doesn't have any stub. Look, once again, when I sent a request to wire mock, it showed me a new log line. Let's imagine that you have any kind of complicated service and you test by log any application. When you send some request to application, you expect to see some log message. And it is not convenient to type the same command many times to see log updates. So similar to Linux tail -f operation, -f stands for follow. You can do actually the same with Docker logs. You can use Docker logs with -f parameter to follow the logs. And now let's open browser, for example, and let's try to access some strange path of wire mock, and it will reply with the same line. But the most important that the same line appeared automatically in our terminal. We didn't need to run the same command again because we are following the log. And to stop following the log, we need to press Control-C operation. Sorry. Well, any questions so far? Well, now let's play a little bit more with Docker containers. Let's look again at our Docker container PS. As I already told you, there are some names. And there are some names that Docker generated themselves in a random manner. But what if I don't like these names and I want to provide my own name? Let's try to do that. Let's imagine that I want to run a container. Let it be wire mock container. Before that, let's stop our container, our running container. Let's run one more wire mock container, but let's try to provide a name to it. And to provide a name, we need to provide parameter -name, and let it be Alice. I don't know why. Let's call our container Alice. Oh, sorry. It says me that there is a parameter minus. Oh. It says that I should use 2 minuses. Yes, it works. Look, we can run docker run -- help. And here we can find an option name. Here it is. And my fault was that I typed name with only one minus, but this parameter requires 2 minuses. That's why it didn't work from the first time. And now let's check what happened with my container. For this purpose, let's run docker container ps -a. Look, there is container with name Alice. And it exited. What will happen if I will try to run container with the same name from the same image again? Let's try to do that. And Docker will respond to me that there is a conflict, because the name is a unique identifier of container. So it is not legal. It is not possible to have 2 containers with the same name. So we need to remove container before starting container with the same name. For this purpose, we can use docker rm, and we can use Alice name to remove our container. And after that, I can run container with the same name again. Well, right now we played with containers, but what if we would like to play with images? Before playing with images, we need to build something to play with. And that is the reason why I decided to conduct this demo in Visual Studio Code. Look, here are 2 different folders: custom wiremock and simple. These are just the names of folders. Look, I have 2 folders here. Command ls shows directories and files inside my current working directory. There are 2 folders. Let's proceed to simple folder. And here I have only one file called Docker file. When we want to build an image, we need to write a Docker file. How a Docker file looks like? Inside Docker file, we have instructions. With blue color, Visual Studio Code highlighted instructions, and white text after instructions are parameters. Let's not think about these instructions right now. Let's consider that this Docker file is correct, and we can build some image from this Docker file. For example, your teammate, developer, asks you to build an image and to test application inside it. What you will do? You will need to ask for a Docker file or to the repository with Docker file. After that, you need to switch to the directory with Docker file, and all you need to do is to write command build, docker build, and after that, you need to provide a path to the folder with Docker file. As you can see right now, my working directory is inside simple folder, which already contains Docker file. So I need to provide a path to the current working directory. To do that, in Linux, I need, or macOS, I need to provide just a dot, which means current working directory. Let's run it, and it shows that building finished. And now I have built some image, but I cannot operate with it because my image is unnamed. I don't know how to interact with it. So to avoid such confusion, we need to provide parameter -t. If you remember my slides, we had slides with some terminology regarding Docker, and there was a term tag. And actually here, -t stands for the tag. But for some reason, here we need to provide not just a tag, here we need to provide image name. And let's call our image simple, why not? Or we can use it, we can call it Bob. And after that, with double dots, we need to provide a version name. If we don't provide anything, it will be the same as tag latest. But for simplicity, let's just provide image name, and it will work. Now it built Bob Docker image, and now we can run our container from this image. Let's start a container from the image that we have just built. Our image name is Bob, so let's run it. Let's run Docker run Bob, and it says hello because actually this container only prints hello. Well, now you know how to build images. But what if you want to build another image with the same name? It will build one more image, and it will have a latest version. So, sorry, just a moment. It will have a latest version as well, because latest tag is considered as latest by type. But what if you want to find your image? For this purpose, we can use Docker images command, and it will print many different images that I have on my PC. On my PC, I have indeed many images because I'm working with Docker for a long time. I use it in my work, so that's why I have many images downloaded. So to find our image Bob, we can use pipe. So we can just pass result of Docker images command to another command, to the command grep, and here we can use grep to find Bob. Look, we have found our Bob. It says latest, and it says that something happened 7 months ago. Why it shows that image was created 7 months ago? Because our image is based on another image, wiremock, that was built 7 months ago. Let me prove it. Let's grab wiremock. Look, I have found wiremock image, and it was built 7 months ago, and that's why the same age was inherited from wiremock. Well, what if I want to remove my image? For this purpose, Docker developers introduced command docker rmi. Why rmi? Because rm stands for remove and I stands for image. And here all we need is to provide image ID. Here it is. Or we need to provide image name. Let's provide image ID. Look, and it says that it cannot remove the image because it is used by stopped container, and it provides a container identifier. Very useful. Let's go and to Docker PS, and let's look at all our containers. Here we have indeed a stop container from Bob image. Let's remove our container, Docker rm Bob. Oh, sorry, not Bob. Docker rm container ID. And now, after that, we can once again can try to remove our Bob image. For this purpose, let's use Docker rmi and provide image ID. Now it says that it successfully deleted it. Let's search for our image again. Now our search result gives nothing for the Bob. It means that we successfully removed our image. Well, now you know how to build an image, you know how to pull an image, and you know how to remove image. But what if you want to remove many images which you have downloaded for containers which were not stopped and were not run? I mean, if you downloaded some image, or if you build some image and you run some containers, after that you removed all these containers, you stopped and removed them, you have many unused images which consume your disk space. And if you want to clean up this space, you can use Docker images prune command. Actually, it says that I don't have any images that can be removed by this command right now. But you need to know, you just need to know about this command. Well, now let's imagine another scenario which you may need in your daily duties as a manual QA engineer. You may need to test some application, and in case if you have found any bug, you may need to get logs of this application and attach it to the bug report. To show this scenario, I prepared a little bit more complicated Docker file. Let me show it. The main feature of this Docker file is that application that we run just redirects all the logs to the file. Actually, in this Docker file, I have a list of instructions which download wiremock. Wiremock is a Java application. That's why this Docker file based on OpenJDK image. OpenJDK is a Java development kit, so it allows to run Java application. So I based on Java development kit image, then I use some instructions to download a Java application, to specify some parameters, and after that I just run Java application, which I downloaded with some parameters, and redirect all the logs to some specific file. Let's try to build an image from this Docker file. To do that, once again, we need to use Docker build command. We need to provide some name. Let it be logs demo. And we need to provide a path to our Docker file. Where this Docker file is located? It is located in folder custom mock. So right now my working directory is a demo folder. Inside demo folder, I have custom mock folder, and inside custom mock folder, I have Docker file. Once again, inside demo folder, I have custom mock, and inside custom mock, I have Docker file that I would like to use to build my image. So let's use Docker build command. Let's provide a name of our image, logs demo, using -t parameter. And let's provide a path. It's a relative path from my working directory to the folder which contains Docker file I need. It says finished. Now I can run container from this image. Sorry, just a moment. Sorry again, let's proceed. Let's run our container from the image logs demo. For this purpose, we need to use Docker run command with -d parameter. Why -d? Because I would like to run mock as a daemon, so that it would not block my terminal and run in background. So I run Docker run with -d parameter, and I provide an image name. Image name is logs demo. This is the name that I provided when I decided to build this image from my Docker file. Look, it responded to me with long representation of container ID. And here, now I can look at my container file system. Let's connect to container file system. To do that, we need to run some command inside our container. To do that, we can use docker exec command. Actually, it stands for docker execute. It means that please run some command inside my container. What we need to do here, we need to provide interactive mode parameter, because in other case it will not run what we need. And after that, we need to provide a name of the command that we need that we want to run. Actually, we would like to run bash that will start terminal inside our container. And after that, let's provide container ID that I copied from here. Oh, it says no container. It looks that something happened with my container. Let's look what happened. For this purpose, we need to run docker container ps. and my container is up and running. Let's try again. Docker exec -at. Oh. It says that it doesn't have bin bash inside. Okay, for some reason it doesn't have bin bash inside. Maybe because I inherited from wrong image, but it's not a problem. Let me show you how to bypass this issue and how to look at container file system. As I told you, we will have a short overview of Docker desktop client. So let me show you right now Docker desktop client, and it will help us to find our log file. Just a moment. Yeah, it is. Can you see some cute program with blue and white interface?
Yes. Yes.
That's great. Look, this is also Docker client, but a little bit beautiful in comparison to a command line interface. It can do almost the same as Docker in command line. Look, here we have in left side containers, images, and something else. Considering that today we have an overview lesson, and today we played with containers and images, let's look at containers and images. Containers. Here we have actually the same what we can see if we run docker container ps -a. So it shows both running and exited containers. And here you can start and stop and remove containers. In the left side, you have images tab. And here you can see a list of images. This is BusyBox that we used to run in the middle of our lesson. And here we can search for any container. Oh, sorry, for any image, logs image, for instance. We can run container from it. We can remove it. And here we can also search for images directly from Docker Hub. For instance, we can search for Python. Look, this is exactly what we have seen in Docker Hub website. I search for Golang, I search for Java, and here it is. Here is also the same warmock. So you can avoid visiting of Docker Hub website, and you can directly find some images from Docker desktop client. And you can do actually absolutely the same what you can do in command line. And here we wanted to find our log file. Let's press on our container, and here is files tab, and it shows container file system. Look, we can go through all the files here, and I know that wiremock is running from this folder, and it saves logs to this file, log.txt file. Here I can also run terminal inside my container. This is exactly what I failed to do right now from the command line, but I did it intentionally just to show you that if you have any problems with a command line interface, there is also an option to use desktop client. And here we can run some commands. We can find all the same files. We can look at files. So as you can see, desktop client has many useful features. But let's return to the command line. Because unfortunately, you will have a desktop client only on your own PC, but for production solutions, Docker is running in some remote servers, and there you will most probably have only terminal access, and you will have most probably an ability only to use command line interface. So let's go back to the command line interface. Here I did a mistake, and I tried to run bin bash from the wrong place. If you look at help of Docker exec, it will say us that first we need to provide container identifier, and after that we need to provide a name of the command that we would like to run. And bash, we just started a terminal inside my container. And here is absolutely the same as I have just showed to you through the Docker desktop client. Here we have the same files, and we can look inside logs. Well, but initial goal of this scenario was to download our logs. And our logs are located in log.txt file, which is located inside wiremock JRE8. So somewhere here by this path. Oh, sorry. By this path. How can we download it? First of all, let's go back to our host machine. Let's exit container terminal. To download our logs, oh, sorry, I have it already. To download our logs, we can use docker cp command. Docker cp stands for docker copy. How to use it? First of all, we need to provide from where our source, and after that, we need to provide destination of copy. Our source is container with this identifier. Once again, I will show you the general way how to find out the identifier of your container. Let's run docker container ps, and our container is up and running. Here is its identifier. So let's use docker cp unique identifier, 2 dots, and after that we need to provide a full absolute path of the file that we would like to copy. This is it, our file path, and after that we need to provide a path where we would like to copy this file on our host machine. Right now, I am in my working directory with name demo, and let's say I would like to copy it to the custom wiremock folder. Let's execute it. Look, now our file is appeared inside custom wiremock folder. Let's look inside custom wiremock folder. Our log.txt file is here. So this is a way how we could copy a file from our container to our host machine. Actually, this is all what we can do with images and containers on our overview lesson. But as I promised, we can talk a little bit about layers and Docker files. Let's go back to the slides. As I told you, I have some tables with comments that we have just executed. Now let's proceed to Docker files. I have also added to the slides some tables with Docker instructions and explanations, so that you will be able to understand what happens inside Docker files. But you don't need to learn it by heart. Let's use it as a cheat sheet. Well, look, this simple scheme explains a lot about layers and instructions. Look, now I will tell you one simple thing, very simplified thing to understand how it works. When you see a Docker file, it is just a list, sequential list of instructions from the top to the bottom. And every instruction adds a new layer. So one instruction is the same as one layer, one by one. But the first instruction, which is usually located on the top, creates the first layer. The second instruction creates the second layer. The third instruction creates the third layer. But let's go back again to our Docker file. Look, the first instruction is from. It means that this Docker file, the image which will be built from this Docker file, will be based on another image with name OpenJDK. Actually, OpenJDK image was also built from another Docker file, which is just a set of just a list of instructions, and it also started from instruction from with another name. And every Docker file adds its own layers when we describe some instructions. Every instruction will add a new layer. But when we want to understand layers from the base images, that we base from, which we inherit from, we need to understand one important thing, that sorry, just a moment. Can you see slides again?
Yes.
That's great. So base images also add some layers when they build from instructions. So instructions from base images, from base Docker files, add some layers. But when we inherit our Docker file from another image, we cannot modify the previous layers. They are immutable for us because they are already packed to the image. And all we can do, we can describe only our own instructions that will add new layers on the top of the layers which were inherited from our base image. The tricky question, what if I don't want to inherit from any image? For that purpose, we need to inherit from scratch. It's just a keyword, which means that we don't inherit from anything. Now, let me show you once again Docker desktop client. And let me show you this image. This is exactly the same image that was built from a Docker file that I have just showed to you, which was inherited from OpenJDK image. Let's press on it. Look, and it shows that my image name is logs demo latest. I have built this image myself. You saw it, and it is based on OpenJDK image. But OpenJDK image is based on build pack depths image of some with some text, which also based on another build pack depths image with another text, and which is based on Debian image. And every image have added its own layer. So 0 layer was added, I guess, from Debian image, and some of these layers were added also from some other images which are listed here. And the last layers, like env VM wiremog, VM version, run workdir wiremog. Look, these are instructions from my Docker file. So these instructions have been added to the end of the layers. Actually, on the top of the layers, but you can imagine this vice versa as a sequential list of instructions of root images to the latest images. That is all what you need to briefly know as a QA engineer about Docker layers. And the last thing that you should know about Docker layers just for the interview is just is that Docker layers count is limited. It's a tricky question to answer what is current limit of Docker layers, because some time ago, some years ago, the limit was 42 or 43. And sometime later, with some Docker updates, the limit was 127. Right now, it can be also increased from version to version. Well, that's all so far for today. Let's go back to the slides. That is all. Thank you so much for your attention. Now it's time for your questions. Please raise your hands. Please write your questions to the chat. If you don't have any questions so far, I guess you know how to contact me, just in case you will review this lesson, and if you will try to repeat all my steps. And in case you have any questions, you can always contact me. Please don't hesitate to do it. Well, thank you so much. I advise you to repeat some steps. I advise you to try Docker yourself. And I wish you all the best on interviews regarding Docker and other topics as well. Thank you.
Thank you.
Thank you so much.
Thank you so much. Goodbye.
Bye.
Oh, sorry. I see one question from Anna. Anna, are you still here?
It was not a question. It was when you tried to write a comment.
Yes, you're right. I did a mistake intentionally, just to have a reason to show your desktop client.
It was tricky.
I will be more transparent the next time. Thank you for the feedback. Well, thank you so much. Have a good day. Goodbye.
Have a good day.